Welcome dear students. We are on the CEC Gurukul lecture and today we are discussing about the one of the most important gadget used in the electronic circuit is the MOSFET. And we discussed the two type of the MOSFET. First is the depletion mode MOSFET that we had discussed in the previous lecture. Now we discuss the next type of MOSFET, that is the enhancement mode MOSFET. And this is the most common enhancement mode MOSFET, or it is also called the E-MOSFET, and is the reverse of the depletion mode type. And here the conducting channel is lightly doped and even undoped, making it non-conductive. So this is the another type of the enhancement MOSFET, and the result in this type of device being normally off, that is non-conducting. And when the gate bias voltage VGS is equal to 0, the circuit symbol we will show in the next device. So when it is off, when the VGS is equal to the 0. And MOS transistor uses a broken channel line to signify normally open non-conducting channel. And for the N channel enhancement, as again it is of the two type, N channel or the P channel. And N channel enhancement MOS transistor, a drain current will only flow when a gate voltage VGS is applied to the gate terminal greater than that of the threshold voltage, that is VTH, in which conductance take place, making it a transconductance device. So in this case, when the gate voltage is applied to the gate terminal greater than that of the threshold voltage, then it will be work as the transconductance device. So the application of the positive gate voltage to the N type of MOSFET, it attracts the more electron towards the oxide layer around the gate, thereby increasing or enhancing the thickness of the channel, allowing more current to flow. So application of the positive gate to the N gate is that it allows the more current to flow. And this is why this kind of transistor is called the enhancement mode device, as the application of the gold voltage enhances the channel. That's why it is called the enhancement MOSFET, or it is the enhance the channel. Increasing the positive gate voltage will cause the channel resistance to decrease, further causing an increase of the drain current, that is ID, through the channel. Or we can say this type of N channel enhancement mode MOSFET plus GS turns the transistor on, while a 0 minus VGS turn the transistor off. Thus the enhancement mode MOSFET is equivalent to the normally open switch. While the reverse is true for the P channel, as VGS is equal to 0, the device is off and the channel is open. And the application of the negative gate voltage of the P type of E MOSFET enhances the channel conductivity, turning it on. Then the P channel enhancement mode MOSFET plus VGS turns the transistor off, minus VGS turns the transistor on in this type of enhancement. This is the P channel enhancement mode MOSFET. There is a two type, when it is plus VGS turns the transistor off and minus VGS turns the transistor on if the voltage is less than that of the threshold voltage. Again, this is a representation of enhancement mode N channel symbols, and you see this is a voltage versus current graph, and how we get the saturation point at the different voltage. It is at the 0, 1, 2, 3, 4, 5 voltage, and we will see clearly then that the current as the voltage increases, the current will increase. Now these are the symbol, you see in between the source and drain there is a broken line. This is a representation of the enhancement type of channel. enhancement. The enhancement MOSFET makes excellent electronic switches due to their low on resistance and extremely high off resistance for as well as their infinitely high input resistance due to its isolated gate. And other uses of the MOSFET is in the integrated circuit, and by using this one can produce the CMOS type of logic gates and the power switching circuits in the form of the PMOS, that is a P channel or NMOS for the N channel gates. So, by using MOSFET we can prepare the PMOS and NMOS, and the CMOS actually stands for the complementary MOS, meaning that is a logic device has both the PMOS and the NMOS within its design, means positive and negative both type is defined by the CMOS. So, enhancement mode having the two type which is PMOS and the NMOS, and if we combine the two then it is a CMOS. What is the working principle of the MOSFET? The main principle of the MOSFET device is to be able to control the voltage and current flow between the source and drain terminal. This MOSFET work on the principle that it control the voltage and current flow between the source and drain terminal, and it works almost like the switch, and the functioning of the devices is based on the MOS capacitor. As it controls the voltage and current flow, so we use the capacitor in it. The MOS capacitor is the main part of the MOSFET. The semiconductor surface of at the below oxide layer, which is located between the source and drain, and can be inverted from P type to N type by the application of either the positive or the negative gate voltage respectively. So, in the MOSFET semiconductor surface at below the oxide layer located between the source and drain on the gate, in between the gate, and that can be inverted for the P type and the negative N type. So, when we apply a repulsive force for the positive gate voltage, then the holes present beneath the oxide layer are pushed downwards with the substrate. You see, there is a oxide layer, oxide SiO2 layer in between the metal, after the metal. You see the middle part of the diagram, left side we have a source, right side we have a drain, in middle one there we are having a gate, and gate is attached with the metal. After the metal there is a oxide layer, and there is a channel, a region where the flow of current takes place, either maybe P type or the N type. And lastly on the bottom there is a body. So, depletion region populates by the bound negative charges which are associated with the acceptor atoms, and when the electrons are reached the channel, as we are talking about the N type, so because we are taking the negative charge, so electrons are reached at the channel is developed. So, the positive voltage also attracts the electrons from the N plus sources and the drained region into the channel, as these electrons are attracted by the hole. So, now if the voltage is applied between the drain and the voltage, the current flows freely between the source and drain, and the gate voltage controls the electrons in the channel. So, instead of positive voltage, if we apply the negative voltage, a whole channel will be formed under the oxide layer, as in the negative voltage it is the electrons, but if we apply a negative voltage, then a whole channel will be formed under the oxide layer, just opposite, a whole channel will be formed under the oxide layer. You see here in the diagram, source and drain, there is a channel region which is a P type of substrate, and here the hole will be shifted from one place to the another place, from source to drain in the channel region. So MOSFET reasons of operations means how, what are the most general scenario. The operation of this device happens mainly in the three reason, and those are as follows. First reason is a cut-off reason, and it is that reason where the device will be in the off condition. There zero amount of current flow through it. If it is in the off condition, then the zero amount of current will flow through it. No current will flow inside the device. So here the device functions as a basic switch and is so employed as when they are necessary to operate as a electrical switches. Second reason is the saturation reason. In this reason, the device will have their drain to the source current value as a constant without considering the enhancement in the voltage across the drain to the source. As we see it in this characteristic, then there is a saturation point. So first point is the cutoff reason, where the voltage is 0 and it is on the off condition, where it is in the saturation point. Saturation point in the reason the device will there drain to the source the current value as a constant without considering the enhancement in the voltage across the drain to the source, and this happens only once when the voltage across the drain to the source terminal increases more than that of the pinch off voltage value. In this case, the device functions as a closed switched, where a saturation level of the current across the drain to the source terminal flows, and due to this saturation reason is selected when the device are supposed to perform switching. So this reason is the bigger reason in the characteristic determination. So next reason is the linear or the ohmic reason, where the current across the drain to the source terminal enhance with the increment in the voltage across the drain to the source path. As the voltage increases, the current, as the current across the drain of the source terminal with increment of the voltage across the drain to the source path. So when the MOSFET device function in this linear reason, they perform amplifier functionality. In the linear ohmic reason, the function of the MOSFET is like an amplifier. So it is the reason where the current across the drain to the source terminal enhances with the increment in the voltage across the drain to the source path, and it is the amplifier, and by this we can get the amplifier functionality. Now let us consider the switching characteristics of the MOSFET. So we have the three reasons in which this MOSFET work. One is the cutoff reason, second is the saturation reason, and third is the linear or ohmic reason. Linear and ohmic reason where it is enhanced, when it is function is will be amplified. So now we consider the switching characteristics of the MOSFET. A semiconductor to such a MOSFET or a bipolar junction transistor is basically functioned as a switches of the two scenario on and off. And if you consider the functionality, then we have to look practically characteristics of the MOSFET device. First is the ideal switch characteristics. When the MOSFET is supposed to function as an ideal switch, then it should hold the below property of those hold the below properties, and these properties are: number one, in on condition there has to be the current limitation that it carries. In the off condition, blocking voltage level should not hold any kind of limitation, right? In the first case, if it is in the on condition, then there has to be the current limitations that is carries out. In the second, when it is off condition, blocking voltage level should not hold any kind of the limitations. When the device function is on state, the voltage drop value should be none, and resistance in the off state should be infinite. This is the ideal switch conditions, and there should be no restrictions on the speed of the operation. That is ideal condition. Now the second is the practical switch characteristics. In this practical switch characteristics, as a world is not just stuck in the ideal application, the functioning of the MOSFET is even applicable for practical purposes. In this case, the device should hold these properties. Number one properties, when it is in the condition of on state, the power managing ability should be limited, which means that the flow of conduction current has to be restricted. And if it is in the on off state, blocking voltage level should not be limited. In the first case it is limited, in the on condition it is limited, but in the off state blocking voltage level should not be limited. So turning on and off for infinite times restricts the limiting speed of the device and even limits the functional frequency in case of the practical switch characteristics. And in the on condition of the MOSFET device, there will be a minimal resistance value, and which results in the voltage drop in case of the forwarding bias. So also there exists finite off state resistance that delivers reverse leakage current. When the device is performing on the practical characteristics, it loses power on state and off state. So this happened even in the two transition stages too. So on and off conditions of the MOSFET device, there will be a finite time restricted of the limiting speed, and in the next case that is result for the voltage drop in the forwarding bias. And the device is performing in the practical characteristics, it loses power on and off condition, and this happens even in the transition state also. Now in the circuit arrangement, if we take of the enhancement type of the n channel MOSFET, which are used to switch the sample lamp and the condition on and off, the positive voltage at the gate terminal is applied to the base of the transistor and the lamp moves into the on condition. And in upper one, when we are talking about the enhancement mode with the n channel, then the used to the switch a sample lamp with the condition of on and off state. But with the positive voltage, the gate terminal is applied to the base of the transistor, the lamp moves into the on condition. Here VGS positive or at 0 voltage. So the device turns to off condition where VGS is equal to 0. So you see here, this is the lamp and this is the condition we define here. This is the flywheel diode, and in between that there is a MOSFET which is connected with the lamp, and V input and V output, and this is the condition for the 0 voltage. Then it is in the off state when it is V plus, then it is in the on state. So if the resistive load of the lamp was to be replaced by the inductive load and connected to the relay or the diode which is protected to the load, and in the above circuit we have seen that it is a very simple circuit for switching a resistive load such as a lamp or the LED. But when using the MOSFET as a switch, either with inductive load or capacitive load, then the protection is required for the MOSFET device. And in case if in the case when the MOSFET is not protected, and it may lead to damage of the devices. For the MOSFET to operate an analog switching devices, it needs to be switching between the cutoff region where the VGS is equal to 0 and saturation region where the VGS is equal to plus V. So, MOSFET can be function as a transistor and it is abbreviated as a metal oxide silicon field effect transistor. So, it is a device that operates as a transistor and it is a P type and an N type. The device connected in such a way using the four sources, four source, gate, drain and terminals, and resistive load of the 24 ohm is connected in the series with an ammeter and the voltage meter is connected across the MOSFET. In the transistor, the current flow in the gate is in the positive direction and the source terminal is connected to the ground. Whereas in the bipolar junction transistor devices, current flow is across the base to ammeter path. But in this device, no current flows between. There is a capacitor at a beginning of the gate and it just requires only the voltage. So, this can be happened by proceeding with the simulation process and by switching on and off. When the switch is on, there is a no current flow across the circuit. When the resistance of the 24 ohm and 0.29 of ammeter voltage are connected, then we find the negligible voltage drop across the source because there is a plus 0.21 voltage across this device. So, the resistance between drain and source is termed as RDS. Resistance between the drain and source is RDS. Due to this RDS, the voltage drop appears when there is a current flow in the circuit, and this RDS varies based on the type of the devices. It can vary in between the 0.001 to 0.005 and 0.5 based on the type of the voltage. So, voltage drop across when there is a current flow in the circuit. This resistance RDS in between the drain and the source. The functionality of MOSFET can be better understood if we go through the various list circuits of the MOSFET, and these circuits can be tried on the breadboard as well as the home. So, we are having a large number of MOSFET that can be used in the various devices as per its application. What are the advantages of the MOSFET? The few advantages we will discuss. Then it generates the enhanced efficiency even when the functioning at the minimum voltage level. Moreover, there is no presence of the gate current. This creates more input impedance, which further provides increased switching speed of the devices, and these devices can function at minimal power level and uses minimal current. What are the basic disadvantages of the MOSFET is when these devices are functioned at the overload voltage levels, it creates instability of the devices. Moreover, as because these devices have a thin oxide layer, so they may create damage to the device when stimulated by the electrostatic charges. And in case of the applications, this MOSFET has many applications, like amplifiers made of MOSFET are extremely employed in extensive frequency applications. Regulation for DC motors are provided by these devices. Moreover, as because these have enhanced switching speed, it acts as perfect for construction of chopper amplifier. Moreover, functions as a passive component for various electronic elements. Apart from this, there are another type of the MOSFET, that is the power MOSFET. As power MOSFET use the methods of semiconductor processing that are similar to the present VLSI circuit, except for level of device voltage current are drastically different in case of the power MOSFET. So nowadays power MOSFET are commonly used, and this MOSFET mainly depends on the original FET, and that launched in the 70s. The power MOSFET invention was done partially through the BJT limitations, and at present this device was choice within the application of the power electronics. So even though it is not feasible to classify the operating limits of a power device completely, because power device can be referred to like any component that can switch as the minimum of the 1 ampere. So in the bipolar power transistor is one kind of device that controls through the current supply. To maintain the device is an on state, the base drive current must be high or compared with the 1/4 of the collector current, and in addition high reverse base drive currents are necessary to achieve quick turn off. So what is the power MOSFET? That is a one kind of the MOSFET which handles high level of power and is known as the power MOSFET, and is compared with the normal MOSFET in the less voltage range, as in compared to the MOSFET in the less voltage range. This MOSFET works much better by exhibiting high speed of switching, and its operating principle is same as that of the general MOSFET. A most widely used MOSFET are the P channel enhancement and an N channel enhancement, and P channel depletion and N channel depletion. The power MOSFET frequency is high, like up to the 400, like the 100 kilohertz. The power MOSFET symbol is defined here. You see, this is the power MOSFET. It is just like similar to that of power MOSFET. So these are the 3 terminal silicon devices that work through applying a signal towards the gate terminals so that it controls the current conduction among source and drain terminal. The current conduction capacities are equal to the thousands of amperes, including breakdown voltage rating from 10 volts to the 1000 volts. For the power MOSFET are available in the different structures depend upon its usability, like vertical diffused MOS or double diffused MOS, and another is the trench diffuse mode. So they are the different type of integrated power circuits. Thank you very much.